This meeting is being recorded.
Hello, my name is Georgios, and in this video I will present my second assessment of mobile robot and manipulator and model robot arm in LabView. As you can see from the first view, this is a robot in 3D screen, robot arm in 3D screen. And here we have the controller system. Two type of one is manual control and second is auto control. For the manual control, I set three controllers. Two of them, one is control X, minus X, and plus X. So if I go to the manual control, I am able to manage X, right and left. If I go to plus X, I control the robot to right. Mine X goes left. Same for Z, plus Z goes up, minus Z go down, and Y is set as a 0, and the reason is we don't want to rotate the robot. We just want it in the same direction, one direction, only up and down and right and left. Now, if I go to the options here in name, go to the home position, the robot, it goes to the home position. Then I have the pickup, they pick up from the floor the item. Then after pickup, it goes to the position 1 and return back. If I go to position 2, for the position 1, it sets 200, for the position 2, 400. If I go to position 3, after doing this, if I go to position 3, 600 millimeter, and pick up 600 millimeter, and set up the manual. Now, in the auto control, second tab, I have the speed, so I can manage the robot for the speed movement. If I want it, depends if I want it really fast or slow. If I want it really fast, it goes 30 or 500. And here is the Boolean button for start, stop the control. So when I started, the robot's gonna start from picking a position, then go to the first position, 200, second position, and third position, and goes back, rotating the same thing. I can make it more fast if I want it. And then when I reach the button, the robot is gonna stop. After complete this, it's gonna stop. And here I have the button, stop button, for stopping the program. Other thing, if I don't reach this button, the robot will work as an auto control, will not stop until I release the button. Otherwise, I cannot control the manual control. And the reason for this is give the robot specific control to follow it. Now going back to this block diagram. So as you see, for beginning the block diagram, I configured my HD parameter. So I have set up my twist angle as initial configuration, so it's upward rather than parallel to the rest of the joint, so I can move along the Y. Then I laid of the arms, which I set here, and all the joint position to revolve. The next is each parameter to configure the robot arm we use. So here I initialize serial arm and choose initial serial arm. For the second simulation, we ignore the dynamic parameter and the error in, and then we continue to give the robot the failed joint angle or initial position. And basically, as you see, the simulation is set position that the robot can start it. So initial position of the robot. So for example, if I made this all 0, the robot it will block up and will give me an error. So I set a specific position, as you can see, these positions, so the robot can start in this position. And also so it will not cross than this. Same thing, it will not go up on this, and the reason again it's will not block the robot and give me an error. So next I'm using forward kinematics. So here I connect the previous angle, current angle that came out is actually convert to my XYZ working current position. So for the basic run from the last run will be fed into forward kinematics, which I will give as my XYZ position, convert from my transfer matrix that X state to give me just X and Z. So it's first element in the array and second element in the array. So those fed into the case structure. I use a case structure for set points, so I can set points. Also here I connect a Boolean button for start and stop the auto control, and this is the top control, and this is time, basically set time until the next MS multiple. So to transfer from the translation connection, it rotate to angle with control XYZ, which, so basically here for the manual control from transfer the connection to rotate degrees for X, Y, and Z, and then connect it to transform from translate connection. So all of them have them control, as you can see. So make another movement happen for tell the robot to move to home position or position 1 or whatever. Is I set to every position different case, like manual control is this one, and goes to home position, which I set home position. So when I sweep, when I change it, it will go directly the choice which I want manually. So pick up, I set 2 points for picking up, goes and picking up. And second is the first position. So I set the pickup positions of this value and offset. So after the robot goes to the first position, then go offset and then pick up again. And I have set a time for 3 seconds. Same thing for second position, changing to a 400 millimeter. And third position, same thing, changing for 600 millimeter, offset and pick up again. All this using the NA and connect the output. So going basic. So after it's send it in array and to our generate central vector, which is here. So this is create a trajectory for the robot to follow. Because in the manual control index, the first it does for the first block. So I do the first joint create from the current position to the block, and then those trajectory points are fed into inverse kinematics. So for each point of the trajectories is fed in one at a time. So first point, and then it's moved to using inverse kinematics. First point, then go inverse kinematics. And then for the next point of the same trajectory, and then once loop is complete, moves to the next block. And so on work like that. So the first completed loop, second, then go to the next point loop, and so on, working like that as a follow. And also that's the reason for this shifts register, these two loops keep looping each other until the entirety of these 4 points are done. So we need the shifts register to keep updating the position. As you can see, I use a 4 kinematics block, and this time is block only search to convert my joint position that we get to a transfer matrix. Move on, you will see enable my XYZ, and we have disabled the rotation. And the reason for this, we don't allow any movement in X, Y, Z. And the reason we have been able to Y, even though we are not using Y, so that we can keep it as a set to 0, so that it doesn't defect to being used solve at all. And here we have my max step. So this is the amount of times that is this way this so will run before it gives up. So when feed the output of that into or the output of the when they feed the output of that into my update plot, then allow us to view the robot in 3D picture. So now going for the auto control. First, the manual control, I set it. I using a Boolean button, so I using false and true. So the false is the manual control. I set false, and then if I press start, then start the manual. True. And in this case structure, so I put all the points in one loop, starting from the first shelf offers. Uh, 200 millimeter, and then set offs. So basically it starts from, this is the pick up positions. Then after picking up, goes to the first loop. The offset first loop. Then goes offset, then second loop, then offset, then third loop. So, and then the Y is connected, all the Y is connected by 0. So first the robot go on a pickup, then go to the first offset 200 millimeter, then offset, then second shelf 400 millimeter, then again offset, then third shelf 600 millimeter, and then offset again, and then pick up, and then home position. And using true false, select the false, using it for the Boolean true false or for the button start and stop, then connect it again to the loop of create certain trajectories. As we explained before, it goes from one to other, and I've complete the first loops, or second loop, second point. And all this, it's set in a white loop with the button stop. And also I set the speed for the generate Cartesian trajectory. Then, as I explained before, we need two loops, these two loops, to keep upload the position that so we need, as we explained before, we need two loops to keep updating. And as I explained before, we need two loops for so we need this. So as I explained before, we need two loops. We need the shift register to keep updating the positions. And thank you.